Welcome back to Cosmos in a Pod Space and Astronomy series.
Episode 12.
Episode 12.
Wow.
Today, we're taking a deep dive into something truly awe-inspiring.
Yeah.
How planets form.
It's amazing.
You know, it's one of those things we often take for granted.
Yeah.
We see the planets in our solar system.
Right.
But have you ever stopped to consider the incredible journey
Oh, yeah.
that brought them into existence?
Absolutely.
From microscopic dust to entire worlds.
I know.
It's a process that spans billions of years
Billions.
and involves a mind-boggling interplay of forces.
It is happening all the time, too.
All the time.
It's not just something that happened in the past.
Right.
It's happening right now as we speak.
That's incredible.
Yeah.
So we've all seen those beautiful artist renderings.
I love those.
The swirling dust clouds giving birth to stars and planets.
It captures the imagination.
It does.
Yeah.
But where does the actual story begin? What's the raw material for these celestial masterpieces?
Well, it all starts with what we call protoplanetary disks.
Protoplanetary disks.
Yeah. Imagine a vast cloud of gas and dust,
Okay.
mostly left over from the birth of a young star.
Okay.
Gravity pulls this material inward, but it doesn't just collapse directly onto the star.
Right.
Instead, due to the conservation of angular momentum,
Right.
you know that principle of physics that keeps a spinning figure skater spinning faster
Oh, yeah.
as they pull their arms in?
Right.
This material starts to rotate and flatten out
Okay.
into a disc shape.
So it's like a cosmic pottery wheel,
Exactly.
shaping this raw material into a flat disk.
Yeah.
And this is where planets begin to emerge.
Exactly. But it's not just a uniform disk.
Okay.
The temperature varies dramatically depending on the distance from the star.
Oh, I see.
Close to the star, it's incredibly hot,
Right.
while further out, temperatures plunge to freezing and beyond.
Okay.
This temperature gradient plays a crucial role
Wow.
in determining what types of planets can form.
So different regions of the disk
Yeah.
are suited for different types of planets.
It's like cosmic zoning.
Cosmic zoning, I like that.
Yeah.
Tell me more about how this temperature gradient affects planet formation.
Okay, so think about it this way.
All right.
In the inner region of the disk, close to the young, blazing star, only heavy elements like metals and rock can withstand the intense heat.
Oh.
These are the building blocks for rocky terrestrial planets like Earth and Mars.
So our planet's fiery beginnings played a key role in shaping its rocky nature.
Absolutely.
What about the outer regions of the disk?
Yes.
Those are where the gas giants like Jupiter and Saturn reside.
Right. Yes, right. As you move further away from the star, past what we call the frost line.
The frost line.
Yeah.
Okay.
The temperature drops significantly.
Okay.
It becomes cold enough for volatile compounds like water, methane, and ammonia
Okay.
to freeze into solid ice.
The frost line. So it's like a crucial boundary.
Yeah, think of it as a dividing line
The dividing line. Okay.
between the realm of rocky planets and the realm of gas giants.
Okay. So inside the frost line,
Yeah,
rocky planets.
rocky planets, and outside
Gas giants.
gas giants and ice giants.
It makes you wonder how different our solar system would be
Right.
if that frost line were located somewhere else.
Absolutely. Yeah.
But let's rewind a bit.
Okay.
We've got these temperature gradients, these different regions in the disk.
Yeah.
But how do we go from tiny dust particles to, actual planets?
Yeah. It's a giant leap.
It is, but it's a journey that happens step by step.
Okay.
It all begins with those tiny dust grains,
All right.
just specks of elements like silicon, carbon, and iron.
Okay.
They're constantly colliding with each other within the disk,
Uh-huh.
and sometimes they stick together.
So it's like a slow and steady cosmic buildup.
Exactly.
So tiny bits of matter gradually coming together.
At first, electrostatic forces help these dust grains cling to each other.
Okay.
But as they grow larger,
Yeah.
their own gravity starts to take over.
Attracting more and more material.
Right.
Eventually, these dust bunnies, we call them pebbles at this stage.
Pebbles.
Yeah.
Okay.
Grow into larger clumps known as planetesimals.
Planetesimals.
Yes,
Okay.
which can range in size from kilometers to hundreds of kilometers across.
So it's like they're starting to resemble something
Right.
we might recognize as a celestial body.
Yeah, they are.
Finally.
But things are still pretty chaotic in the protoplanetary disk.
Okay.
Imagine a cosmic demolition derby
Wow.
with these planetesimals constantly crashing into each other.
Oh, wow.
Some collide and shatter into smaller pieces,
Right.
while others merge together and grow larger.
So it's like a game of cosmic bumper cars,
It is.
with only the strongest surviving.
Yeah, you could do that.
And it's fascinating to think about this early period of intense activity.
Yeah,
And how it shaped the planets we see today.
absolutely.
So what happens to the planetesimals that manage to survive this chaotic phase?
The survivors of this cosmic demolition derby?
Right. The ones that manage to pull through and keep growing evolve into what we call protoplanets.
Yeah.
So these protoplanets, they're kind of like the seeds of planets.
Right, those almost planets still clearing a path and gathering material. It
Exactly.
makes you wonder if things ever settle down in a planetary system?
Well, that's where we get to a concept called planetary migration.
Planetary migration.
Yeah.
Okay, that throws a wrench into the idea of a neatly ordered solar system.
It does.
What could possibly cause a planet to just up and relocate?
It's all about gravity.
Gravity.
Planets exert a gravitational pull on each other, and that can lead to some complex interactions.
Oh, okay.
Imagine a cosmic dance
I like that.
where the gravitational forces from other planets, or even the remaining gas and dust in the disk,
Right.
can nudge a planet out of its original orbit.
So it's a cosmic game of tug of war
Yeah,
with gravity as the rope.
pretty much.
And these gravitational tugs can cause a planet to migrate either inward or outward precisely. And that migration can have a dramatic impact on the structure of a planetary system.
Wow.
Some planets might end up closer to their star, while others might drift further out.
Okay.
It can even lead to planets being ejected from the system entirely.
Wow, that completely changes the picture of a static, unchanging solar system.
It does.
It's more like a dynamic, evolving environment with planets shifting positions over millions of years.
Absolutely. That's a much better way to think about it.
Are there any examples of this migration in our own solar system?
There's a good chance our very own Jupiter might have undergone a period of migration early in its history.
Jupiter on the move?
Yeah, some models suggest it might have formed further out from the sun
Okay.
and then gradually migrated inward to its current position.
Wow.
Think of the impact that would have had on the rest of the solar system.
What makes scientists think that happened?
It's a bit like detective work, looking for clues from the structure of our solar system.
Okay.
One piece of evidence lies in the asteroid belt between Mars and Jupiter. Some scientists believe that Jupiter's migration might have disrupted this region, scattering asteroids and preventing a planet from forming there.
Interesting.
It's a bit like Jupiter leaving a cosmic trail behind as it moved inward.
So Jupiter's journey might have sculpted the asteroid belt as we know it today.
Exactly. It's like a cosmic ripple effect,
It really is.
with one planet's movements impacting the entire system.
But let's shift gears a bit.
Okay.
We talk about gravity shaping planets and their orbits.
Right.
But there's another force at play that we haven't touched on yet.
Oh, yeah.
Magnetic fields.
They're fascinating.
What role do they play in this whole process?
Magnetic fields are often overlooked,
Yeah.
but they play a significant role in the early stages of planet formation.
Okay.
Remember those protoplanetary disks, the birthplaces of planets?
Right.
Well, they're not just swirling clouds of gas and dust.
Right.
They're also threaded with magnetic fields, which can influence how material moves and interacts within the disk.
Yeah. So magnetic fields add another layer of complexity to this already intricate process.
They do.
What kind of influence do they have?
Think of magnetic fields as invisible threads,
Okay.
weaving through the disk and influencing the flow of material.
Okay.
They can create turbulence and instabilities,
Right.
which can affect the growth of planetesimals and the formation of protoplanetary cores.
So they can really shake things up.
They can, and they can even drive powerful jets of material outward from the star,
Wow.
carving out cavities in the disk.
It sounds like magnetic fields can be both creative and destructive forces,
They are.
shaping the environment where planets are born.
Yeah, it highlights the interconnectedness of everything in the universe.
That's fascinating.
Gravity, magnetism, radiation, they all work together,
Wow.
like a cosmic orchestra, to create the planets and solar systems we observe today.
This deep dive has been full of surprises.
It has.
We've gone from tiny dust particles to migrating planets
It's an amazing journey.
and the invisible hand of magnetic fields.
It is.
I'm starting to think that planet formation is less about simple accretion
Right.
and more about a complex dance of forces, each playing a crucial role in shaping the final outcome.
That's a great way to put it. And as we continue to study planet formation, we're realizing that it's an even more complex and dynamic process than we ever imagined.
Welcome back to the final part of our deep dive into planet formation.
The grand finale.
You know, it's amazing to think about everything we've covered so far,
Yeah.
from those initial dust particles to migrating planets and the influence of magnetic fields.
It's mind-blowing.
It really paints a picture of a dynamic and ever-evolving universe.
It does, and it makes you realize that our understanding of planet formation is constantly evolving
Absolutely.
as we make new discoveries and refine our models.
Speaking of new discoveries, one of the most exciting areas of research today
Yeah.
is the search for planets beyond our solar system.
Exoplanets?
Exoplanets, especially those that might be similar to Earth.
Right.
We've discovered thousands of exoplanets already.
It's incredible.
But the quest for another Earth, a planet that could potentially support life,
Yeah.
it really captures the imagination.
It does, and the pace of discovery has been incredible in recent years.
It has.
We're finding planets of all sizes and types,
Oh, wow.
orbiting different kinds of stars.
It's amazing.
But what really gets people excited are those planets that fall within what we call the habitable zone.
Right, the Goldilocks zone.
Exactly.
Not too hot, not too cold, just right for liquid water to exist on the surface.
That's the sweet spot.
That's considered a crucial ingredient for life as we know it.
Absolutely.
So are we finding many planets in these habitable zones?
We are, and as our telescopes and observation techniques become more sophisticated,
Yeah.
we're able to study these exoplanets in greater detail.
That's exciting.
We're not just detecting their presence,
Right.
we're starting to characterize their atmospheres
Oh, wow.
and look for signs that might indicate the presence of life.
So it's like we're playing cosmic detective, looking for clues on these distant worlds. What kind of signs are we looking for?
We're searching for what we call biosignatures.
Biosignatures.
Yes, specific molecules or combinations of molecules in a planet's atmosphere that could indicate biological activity.
Oh, I see.
Oxygen is a key one,
Oxygen.
especially when found in combination with gases like methane or ozone.
Okay.
These gases can be produced by living organisms and could be a telltale sign that we're not alone in the universe.
It's mind-boggling to think that we might be on the verge of detecting signs of life on other planets.
Yeah.
It would truly revolutionize our understanding of our place in the cosmos.
It would change everything.
But the search for life isn't the only exciting frontier in planet formation, right?
Right.
What else are researchers focusing on?
One area that's particularly fascinating is the study of planetary systems around different types of stars.
Oh, okay.
For a long time, we focused on stars like our sun,
Right.
but we're now realizing that stars come in a wide variety of sizes, masses, and temperatures, and that diversity has a huge impact on the types of planets that can form.
So it's not just a one-size-fits-all recipe for planet formation.
It's not. No.
The type of star sets the stage for the kinds of planets that might emerge.
Exactly. Take red dwarf stars, for example.
Red dwarf stars.
They're much smaller and cooler than our sun, and they're incredibly common in the Milky Way galaxy.
Like,
Their habitable zones are much closer in,
Yeah.
which means that planets in those zones would experience stronger gravitational forces from the star.
so planets around red dwarfs would be baked on one side and frozen on the other.
Pretty much, yeah.
That sounds like a pretty extreme environment for life as we know it.
It does, but it also raises some really interesting questions about the adaptability of life.
Right.
Could life find a way to thrive in such extreme conditions?
It makes you wonder.
We just don't know yet.
Right.
And that's what makes it so exciting to study.
This deep dive has been a real eye-opener. It's clear that planet formation is a much more complex and nuanced process than I ever imagined.
And any of us imagined.
We've gone from thinking about simple collisions to exploring the influence of gravity,
Right.
magnetic fields, planetary migration, and the characteristics of different types of stars.
It's quite a journey.
It's incredible to see how all these factors come together to create the incredible diversity of planets we observe in the universe.
And the journey of discovery is far from over.
Right.
There are still so many unanswered questions and mysteries to unravel.
Like what?
How exactly do protoplanetary disks evolve and give rise to planetary systems?
That's a good question.
What role do giant impacts play in shaping planets and their moons? And perhaps the biggest question of all, are we alone in the universe?
It's both humbling and inspiring to realize how much we still don't know.
It is.
But it's also a testament to human curiosity and our drive to explore the unknown.
Absolutely.
Thank you for taking us on this incredible journey through the fascinating world of planet formation.
It's been my pleasure.
And to our listeners, thank you for joining us on this episode of Cosmos in a Pod.
Until next time.
We hope you enjoyed our deep dive into planet formation. Don't forget to follow and subscribe to the podcast for more explorations of the cosmos.